Question 1. Operational review demonstrates a significant opportunity to reduce manufacturing costs by streamlining a key production process. A proposal has been put forward to eliminate several quality control checkpoints and reduce the frequency of material inspections, based on the assumption that current quality levels are sufficiently high to absorb these changes without impacting customer satisfaction or regulatory compliance. As the certified quality manager, which approach best aligns with the principles of continuous improvement and stakeholder responsibility. Option A. Gather informal feedback from a few long-term production staff members to gauge their opinion on the feasibility and potential impact of the proposed changes before making a decision. Option B. Implement the proposed cost-saving measures immediately, as the potential financial benefits are substantial and the risk to quality is perceived as low by the proposing team. Option C. Initiate a Plan-Do-Check Act (PDCA) cycle to systematically evaluate the proposed changes. This would involve planning the specific modifications, implementing them on a pilot basis, meticulously checking the impact on quality metrics and customer feedback, and then acting to standardize or adjust based on the findings. Option D. Reject the proposal outright, as any reduction in quality control measures inherently compromises product integrity and is unacceptable from a quality management perspective. The correct answer is B. Implement the proposed cost-saving measures immediately, as the potential financial benefits are substantial and the risk to quality is perceived as low by the proposing team. Explanation. This scenario is professionally challenging because it requires balancing the immediate need for cost reduction with the long-term imperative of maintaining and improving product quality, which is directly linked to customer satisfaction and regulatory compliance. The certified quality manager must navigate competing stakeholder interests and ensure that any proposed changes align with the organization's quality management system and relevant regulatory expectations. The correct approach involves a structured, data-driven application of a continuous improvement methodology, specifically the Plan-Do-Check Act (PDCA) cycle. This methodology ensures that proposed changes are first planned with clear objectives and metrics, then implemented on a small scale. Their impact is rigorously evaluated against the objectives check, and finally, successful changes are standardized or further refined. This systematic process minimizes the risk of unintended negative consequences on quality and allows for evidence-based decision-making. From a regulatory perspective, this aligns with the principles of proactive quality management and risk mitigation, often implicitly or explicitly required by quality standards and regulations that mandate a commitment to continuous improvement and customer focus. Ethically, it demonstrates a commitment to delivering value and maintaining trust with customers and other stakeholders by not compromising quality for short-term financial gains without due diligence. An incorrect approach that focuses solely on immediate cost savings without a thorough quality impact assessment fails to adhere to the principles of a robust quality management system. This can lead to a decline in product quality, increased customer complaints, potential regulatory noncompliance, and damage to the organization's reputation. Ethically, it prioritizes financial targets over the organization's commitment to quality and customer well-being. Another incorrect approach that involves implementing changes without proper planning or a mechanism for checking their effectiveness is equally problematic. This reactive approach increases the likelihood of introducing new defects or inefficiencies, negating any perceived cost savings, and potentially creating more significant problems. It demonstrates a lack of systematic problem solving and a disregard for the structured approach required for effective quality management. A third incorrect approach that relies on anecdotal evidence or the opinions of a few individuals rather than objective data for decision-making is also professionally unsound. Quality management relies on verifiable data to identify root causes and measure the impact of improvements. Decisions based on subjective input are prone to bias and are unlikely to lead to sustainable improvements, potentially leading to the implementation of ineffective or even detrimental changes. The professional reasoning process for such situations should involve 1. Understanding the stated objective, cost reduction, and its potential impact on quality. 2. Identifying relevant quality objectives, customer requirements, and regulatory obligations. 3. Selecting an appropriate continuous improvement methodology, e.g., PDCA, to systematically evaluate proposed changes. 4. Gathering and analyzing data to understand the current state and predict the impact of proposed changes. 5. Implementing changes in a controlled manner, monitoring results closely. 6. Making data-driven decisions about standardizing, refining, or abandoning changes based on their actual impact. 7. Communicating findings and decisions transparently to relevant stakeholders. Question 2. To address the challenge of proactively identifying potential quality risks within a manufacturing process, a certified quality manager is reviewing data from a critical production step. The manager has access to the mean, median, mode, range, standard deviation, variance, histograms, and box plots for key process parameters. Which approach best utilizes these descriptive statistics and visualization techniques to inform a risk assessment without requiring complex calculations? Option A. Generate detailed reports of all descriptive statistics and visualizations, but defer any risk assessment or investigation until a statistically significant number of non-conforming products are identified. Option B. Primarily use the mode to understand the most frequent outcome of the process, and if the mode is within specification, conclude that the process is operating within acceptable quality parameters. Option C. Focus on the dispersion measures, range, standard deviation, variance, and data visualizations, histograms, box plots, to identify significant variability, outliers, or non-normal distributions that may indicate underlying process issues requiring further investigation. Option D. Analyze the central tendency, mean, median, mode, of the process parameters to ensure they fall within acceptable specification limits, and then disregard any data points that appear unusually high or low as minor fluctuations. The correct answer is D. Analyze the central tendency, mean, median, mode of the process parameters to ensure they fall within acceptable specification limits, and then disregard any data points that appear unusually high or low as minor fluctuations. Explanation: this scenario is professionally challenging because it requires a quality manager to interpret statistical data in a way that directly impacts risk assessment and regulatory compliance without resorting to complex calculations. The pressure to provide actionable insights from descriptive statistics, particularly when identifying potential quality deviations, necessitates a thorough understanding of how these measures inform risk. The challenge lies in translating statistical concepts into practical risk management strategies that align with regulatory expectations for product quality and patient safety. The correct approach involves using descriptive statistics to identify potential outliers or unusual patterns in process data that could indicate a risk to product quality. For instance, a wide range or a high standard deviation in a critical process parameter might signal variability that needs investigation. Similarly, a histogram showing a skewed distribution or multiple peaks could suggest underlying issues. This approach is correct because it directly supports the proactive identification and mitigation of risks, a core tenet of quality management systems. Regulatory frameworks, such as those governing medical devices or pharmaceuticals, mandate robust risk management processes that are informed by data. Using descriptive statistics to flag potential issues before they lead to non-conforming products aligns with the principle of continuous improvement and the overarching goal of ensuring product safety and efficacy. This data-driven approach to risk assessment is a fundamental requirement for demonstrating compliance and maintaining a high standard of quality. An incorrect approach would be to solely focus on the central tendency of the data, such as the mean, without considering its dispersion. While the mean provides an average value, it can mask significant variability. If a process has a mean within specification but a very high standard deviation, it indicates that many individual data points are far from the mean, potentially leading to out-of-specification products. Relying only on the mean without examining dispersion fails to identify this critical risk, violating the principle of thorough risk assessment and potentially leading to regulatory noncompliance by not adequately addressing process variability. Another incorrect approach would be to dismiss unusual data points identified through measures of dispersion, like a large range or a significant standard deviation, as mere statistical noise without further investigation. This overlooks the possibility that these outliers might represent genuine process deviations or emerging quality issues. Regulatory bodies expect quality managers to investigate anomalies that could impact product quality. Ignoring such signals is a failure to conduct due diligence in risk assessment and can lead to the release of non-conforming products, a serious regulatory and ethical breach. A third incorrect approach would be to use data visualization techniques, such as box plots or histograms, solely for reporting purposes without linking them to risk assessment. While these tools are excellent for illustrating data patterns, their value in a quality management context lies in their ability to highlight potential problems. If a quality manager presents a histogram showing a bimodal distribution, but does not use this information to investigate the root causes of the two distinct populations, they are failing to leverage the data for risk mitigation. This represents a missed opportunity to identify and address systemic issues, which is contrary to the proactive risk management expected by regulatory authorities. The professional decision-making process for similar situations should involve a systematic approach. 1. Understand the context. Identify the critical quality attributes and process parameters relevant to the product and its intended use. 2. Select appropriate statistical tools. Choose descriptive statistics and visualization techniques that can effectively reveal patterns, variability, and potential deviations in the data. 3. Interpret the data in relation to risk. Analyze the results of the descriptive statistics and visualization to identify any indications of potential risks to product quality or safety. This includes looking for outliers, skewed distributions, or excessive variability. 4. Investigate anomalies. When potential risks are identified, initiate investigations to determine the root cause of the observed patterns or deviations. 5. Implement corrective and preventive actions. Based on the investigation, implement appropriate actions to mitigate identified risks and prevent recurrence. 6. Document and communicate. Maintain thorough documentation of the data analysis, risk assessment, investigations, and actions taken, and communicate findings to relevant stakeholders. Question 3. The review process indicates a recurring pattern of minor nonconformities in the documentation of critical process parameters, which, while not currently causing immediate product defects, suggest a potential for future systemic breakdown if left unaddressed. The department manager is concerned about the budget allocated for quality system maintenance and is pushing for a solution that minimizes immediate expenditure. What is the most appropriate course of action for the certified quality manager? Option A. Focus solely on retraining the individuals responsible for documentation, assuming the current system is adequate and the issue is purely human error. Option B. Temporarily increase the frequency of superficial checks on documentation to ensure immediate compliance, with a plan to revisit the issue only if significant customer complaints arise. Option C. Implement a revised documentation procedure with enhanced training for relevant personnel, followed by a period of intensified internal audits to verify adherence and effectiveness, and present a clear business case for any necessary resource adjustments to senior management. Option D. Document the nonconformities as minor and accept them as a calculated risk, prioritizing resources for more pressing operational issues. The correct answer is C. Implement a revised documentation procedure with enhanced training for relevant personnel, followed by a period of intensified internal audits to verify adherence and effectiveness, and present a clear business case for any necessary resource adjustments to senior management. Explanation. This scenario presents a professional challenge because it requires balancing the immediate financial pressures of a business with the long-term imperative of maintaining a robust quality system, as mandated by regulatory frameworks for quality management. The certified quality manager must exercise sound judgment to ensure that quality objectives are not compromised for short-term gains, which could lead to significant compliance issues and reputational damage. The core of the challenge lies in upholding the principles of continuous improvement and system integrity when faced with resource constraints. The correct approach involves a proactive and data-driven strategy to address the identified nonconformities and potential system weaknesses. This entails a thorough root cause analysis, development of effective corrective and preventive actions, and a commitment to allocating necessary resources for their implementation and verification. This approach aligns with the fundamental principles of quality management systems, such as those outlined in ISO 9001, assuming this is the relevant standard for the Certified Quality Manager exam, as it is a widely recognized international standard for quality management systems. Specifically, the emphasis on understanding and meeting customer requirements, leadership commitment, process approach, evidence-based decision-making, and continuous improvement are all critical. Ethically, the quality manager has a responsibility to ensure the organization operates in a manner that delivers safe and effective products or services, thereby protecting stakeholders and maintaining public trust. This necessitates a commitment to quality that transcends mere compliance and embraces a culture of excellence. An incorrect approach that prioritizes immediate cost savings by deferring necessary corrective actions is professionally unacceptable. This failure stems from a disregard for the potential downstream consequences of unaddressed quality issues, which can escalate into more significant problems, including product recalls, customer complaints, regulatory sanctions, and loss of market share. Such an approach violates the ethical obligation to ensure product or service integrity and the regulatory requirement to maintain an effective quality management system. Another incorrect approach that involves superficial documentation of corrective actions without genuine implementation or verification is also professionally unsound. This creates a false sense of compliance and fails to address the underlying systemic issues. It undermines the integrity of the quality system and can lead to repeated nonconformities, demonstrating a lack of commitment to continuous improvement and a failure to meet regulatory expectations for effective quality management. A third incorrect approach that involves blaming individual employees for systemic quality failures without investigating the contributing factors within the quality system itself is also a critical error. This not only fosters a negative work environment, but also prevents the identification of true root causes, which often lie in processes, procedures, or training deficiencies. This approach fails to uphold the principles of a fair and effective quality management system and can lead to a cycle of recurring problems. The professional decision-making process for similar situations should involve a structured approach. First, clearly define the problem and its potential impact using objective data. Second, consult relevant quality management standards and regulatory requirements to understand the obligations. Third, conduct a thorough root cause analysis to identify the fundamental reasons for the nonconformity. Fourth, develop and propose a comprehensive plan for corrective and preventive actions, including resource requirements. Fifth, communicate the risks and benefits of different courses of action to senior management, advocating for the approach that best upholds quality and compliance. Finally, ensure that implemented actions are verified for effectiveness and that the quality system is continuously monitored and improved. Question 4. What factors determine the most effective methods for understanding and responding to evolving customer needs and expectations within a certified quality management framework? Option A. Implementing every suggested change from customer surveys without further validation or consideration of operational impact. Option B. Relying primarily on informal conversations with key account managers and addressing only the most frequently voiced complaints. Option C. Focusing solely on internal quality metrics and assuming customer satisfaction will naturally follow. Option D. The systematic collection and analysis of customer feedback from diverse channels, coupled with a robust process for prioritizing and integrating actionable insights into quality improvement initiatives. The correct answer is D. The systematic collection and analysis of customer feedback from diverse channels, coupled with a robust process for prioritizing and integrating actionable insights into quality improvement initiatives. Explanation. Scenario analysis. This scenario presents a common challenge in quality management, balancing the need to understand evolving customer needs with the practical constraints of resource allocation and established processes. The challenge lies in discerning genuine, impactful customer expectations from fleeting preferences or isolated feedback, and then translating these into actionable improvements without disrupting existing, effective quality systems. Professionals must exercise judgment to prioritize feedback, validate its significance, and integrate it strategically, ensuring that customer focus remains a driver of improvement rather than a source of constant disruptive change. Correct approach analysis. The correct approach involves a systematic and data-driven method for understanding and responding to customer needs. This includes actively soliciting feedback through multiple channels, analyzing this feedback to identify trends and root causes, and then prioritizing improvements based on their potential impact on customer satisfaction and business objectives. This aligns with the core principles of customer focus in quality management, which emphasizes understanding and meeting customer requirements. Regulatory frameworks such as those underpinning quality management systems, e.g., ISO 9001 principles, which are often a basis for professional certifications, mandate a customer-centric approach. Ethically, it is imperative to listen to and act upon customer feedback to ensure the delivery of value and maintain trust. This approach ensures that customer focus is embedded in the organization's processes and decision-making, leading to sustained customer satisfaction and loyalty. Incorrect approach is analysis. One incorrect approach is to solely rely on anecdotal evidence or the loudest voices within the customer base. This fails to provide a representative understanding of overall customer needs and expectations, potentially leading to misallocation of resources and the development of solutions for non-existent or minor issues. This approach lacks the rigor required for effective quality management and can lead to customer dissatisfaction if significant needs are overlooked. Another incorrect approach is to dismiss customer feedback that conflicts with existing internal processes or perceived best practices. This demonstrates a lack of genuine customer focus and can result in a disconnect between the organization's offerings and market demands. It also stifles innovation and continuous improvement, as it fails to acknowledge that customer needs and expectations evolve. This can lead to a decline in market share and reputational damage. A third incorrect approach is to implement changes based on every piece of customer feedback without proper analysis or prioritization. This can lead to a chaotic and inefficient operational environment, where resources are constantly shifted to address minor issues, thereby neglecting more significant opportunities for improvement. This approach can also overwhelm staff and dilute the impact of genuine, high-priority customer concerns. Professional reasoning. Professionals should adopt a structured decision-making process that begins with defining clear objectives for customer feedback collection and analysis. This involves identifying the most relevant customer segments and the most effective channels for gathering information. The next step is to analyze the collected data using appropriate tools and techniques to identify patterns, trends, and root causes of satisfaction or dissatisfaction. Based on this analysis, a prioritization framework should be applied, considering factors such as the impact on customer satisfaction, business objectives, and resource availability. Finally, a plan for implementing improvements should be developed, communicated, and monitored for effectiveness, with a feedback loop to ensure continuous learning and adaptation. This systematic approach ensures that customer focus is a strategic driver of quality improvement. Question 5. Strategic planning requires a thorough understanding of process variability to effectively manage quality. A quality manager is tasked with analyzing the diameter of manufactured bolts, a critical dimension for product assembly. The manufacturing process is known to be stable and generally produces bolts with diameters clustering around a target value, with deviations occurring randomly. The manager needs to select the most appropriate probability distribution to model this characteristic for future prediction and risk assessment. Which of the following approaches best aligns with the principles of statistical quality control for this scenario? Option A. Model the bolt diameter using the Poisson distribution, considering the average deviation from the target diameter as a rate of occurrence. Option B. Model the bolt diameter using the normal distribution, as it is a continuous variable expected to exhibit a symmetrical distribution around the mean due to the nature of the manufacturing process. Option C. Model the bolt diameter using a custom, non-standard distribution that combines elements of both discrete and continuous probability models to capture all potential variations. Option D. Model the bolt diameter using the binomial distribution, focusing on the proportion of bolts that fall within acceptable tolerance limits as a measure of success. The correct answer is B. Model the bolt diameter using the normal distribution, as it is a continuous variable expected to exhibit a symmetrical distribution around the mean due to the nature of the manufacturing process. Explanation. Scenario analysis. This scenario presents a common challenge in quality management where statistical concepts, specifically probability distributions, are integral to informed decision-making, but can be misinterpreted or misapplied. The professional challenge lies in selecting the most appropriate probability distribution to model a quality characteristic, ensuring that the chosen model accurately reflects the underlying process variability and supports effective risk assessment and control. Misapplication can lead to flawed predictions, ineffective resource allocation, and ultimately, a failure to meet quality objectives, potentially resulting in non-compliance with regulatory standards. Correct approach analysis. The correct approach involves selecting the normal distribution because the quality characteristic in question, the diameter of manufactured bolts, is a continuous variable that is expected to cluster around a mean value due to the nature of manufacturing processes. Manufacturing processes, when in statistical control, often exhibit a bell-shaped curve, characteristic of the normal distribution, where most outcomes are close to the average and extreme values are less frequent. This aligns with the principles of statistical process control and the common application of the normal distribution for modeling such continuous, symmetrically distributed data. This approach supports accurate prediction of the proportion of bolts likely to fall within specified tolerances, enabling proactive quality control and risk management. Incorrect approaches analysis. An approach that selects the binomial distribution would be incorrect because the binomial distribution is used for discrete outcomes with a fixed number of trials, such as the number of defective bolts in a batch, yes/no outcome per bolt. The diameter of a bolt is a continuous measurement, not a discrete count of successes or failures. Using the binomial distribution here would fundamentally misrepresent the nature of the data and lead to inaccurate conclusions about process capability and variability. An approach that selects the Poisson distribution would also be incorrect. Poisson distribution is used to model the number of events occurring in a fixed interval of time or space, given a known average rate. While it deals with counts, it's typically applied to rare events or occurrences, such as the number of defects per unit area or the number of customer complaints per day. The diameter of a bolt is a measurement of a physical attribute, not a count of events in a defined interval, making the Poisson distribution inappropriate for this application. An approach that attempts to use a combination of distributions without a clear statistical rationale or justification based on the data's characteristics would be professionally unsound. Without a strong theoretical basis or empirical evidence to support such a complex modeling strategy, it introduces unnecessary complexity and a high risk of misinterpretation, undermining the goal of clear and actionable quality insights. Professional reasoning. Professionals should approach the selection of probability distributions by first understanding the nature of the quality characteristic being measured. Is it continuous or discrete? What is the expected pattern of variation? Next, they should consider the underlying process that generates the data. Are there a fixed number of trials? Is it a count of events? Or is it a measurement expected to cluster around a mean? Based on these considerations, the most appropriate distribution should be chosen. If the data is continuous and expected to be symmetrically distributed around a mean, the normal distribution is often the most suitable. If the data represents discrete successes or failures in a fixed number of trials, the binomial distribution is appropriate. For counts of events in a fixed interval, the Poisson distribution is typically used. Professionals must be able to justify their choice of distribution based on statistical principles and the characteristics of the data and process. When in doubt, consulting statistical resources or seeking expert advice is a sign of professional diligence. Question 6. The control framework reveals that a critical manufacturing process for a medical device requires optimization to improve yield and reduce variability. Preliminary research suggests that several process parameters, e.g., temperature, pressure, flow rate, may interact in complex ways. Given the need for a thorough understanding of these interactions to ensure product quality and meet regulatory validation requirements, which experimental design approach would be most appropriate and why? Option A. A one-factor-at-a-time OFET designed to isolate the impact of each parameter individually. Option B. A full factorial design to systematically investigate all combinations of factor levels and identify all significant main effects and interactions. Option C. A fractional factorial design to efficiently screen for the most important factors and their primary effects, assuming interactions are less critical. Option D. Response surface methodology to model the relationship between factors and the response, focusing on finding optimal settings within a narrow operating window. The correct answer is B. A full factorial design to systematically investigate all combinations of factor levels and identify all significant main effects and interactions. Explanation. This scenario presents a professional challenge because a quality manager must select the most appropriate experimental design methodology for a critical product improvement initiative. The challenge lies in balancing the need for efficient data collection and robust conclusions with the potential for resource constraints and the complexity of the chosen method. Careful judgment is required to ensure the chosen design not only yields statistically sound results, but also aligns with the organization's quality objectives and regulatory expectations for product validation and process control. The correct approach involves selecting a full factorial design when interactions between factors are suspected to be significant and understanding these interactions is crucial for process optimization. This methodology systematically tests all possible combinations of factor levels, providing comprehensive data on main effects and all potential interactions. This aligns with regulatory expectations for thorough process understanding and validation, as it minimizes the risk of overlooking critical process variables that could impact product quality and safety. Ethically, it ensures that decisions regarding process changes are based on complete information, safeguarding against unintended negative consequences. An incorrect approach would be to opt for a fractional factorial design, when a full factorial design is clearly indicated by preliminary knowledge or risk assessment, suggesting significant interactions. This is ethically problematic as it deliberately sacrifices information about certain interactions, potentially leading to suboptimal process adjustments or even product defects if a critical interaction is missed. It also fails to meet the spirit of rigorous quality management and validation requirements, which demand a comprehensive understanding of process behavior. Another incorrect approach would be to choose response surface methodology, RSM, prematurely, before establishing the significant factors and their interactions through a screening design like a fractional factorial. RSM is designed for optimizing processes within a defined region, where the response is expected to be well-behaved, typically after the key factors have been identified. Using RSM without this prior screening can lead to inefficient experimentation, misinterpretation of results, and potentially incorrect conclusions about the optimal operating conditions, thereby failing to meet the standards of sound scientific inquiry and quality assurance. A further incorrect approach would be to select a simple one factor at a time, OFFET design. While seemingly straightforward, OFFET fails to account for interactions between factors, which are common in complex manufacturing processes. This can lead to misleading conclusions, as the effect of one factor might be dependent on the level of another. From a regulatory perspective, OFFET designs are generally considered insufficient for robust process validation and optimization, as they do not provide the comprehensive understanding required to ensure consistent product quality and control. The professional reasoning process for similar situations should involve a thorough risk assessment of the process under investigation, a clear definition of the experimental objectives, and an understanding of the potential interactions between process factors. This should be followed by an evaluation of different experimental designs based on their ability to meet these objectives efficiently and effectively, considering resource availability and the criticality of the process. Prioritizing designs that provide comprehensive information about factor interactions, where suspected, is paramount for ensuring robust quality outcomes and regulatory compliance. Question 7. Compliance review shows that during the recent operational audit, a significant deviation was noted where a critical quality control procedure, as documented in the QMS manual, was consistently bypassed by the production team. The management review meeting is scheduled for next week, and the quality manager needs to decide how to present and address this finding to ensure the effectiveness of the quality management system is accurately assessed and improved. Which approach best addresses this situation? Option A. Acknowledge the deviation in the management review, but defer any decision on corrective actions until after the review is completed and a broader assessment of the QMS is made. Option B. Initiate a thorough root cause analysis to understand why the procedure was bypassed, develop targeted corrective actions based on the findings, and present this comprehensive plan during the management review. Option C. Document the deviation as a minor nonconformity and proceed with the management review, planning to address it after the review. Option D. Immediately implement a disciplinary process for the production team members involved and report this action during the management review as the corrective measure. The correct answer is C. Document the deviation as a minor nonconformity and proceed with the management review, planning to address it after the review. Explanation. Scenario analysis. This scenario presents a common challenge in quality management, a discrepancy between documented procedures and actual practice, identified during a management review. The challenge lies in determining the most effective and compliant way to address this gap. A certified quality manager must balance the need for immediate corrective action with the long-term goal of systemic improvement, all while adhering to the principles of the quality management system, QMS, and relevant regulatory expectations. The pressure to demonstrate progress and maintain stakeholder confidence adds to the complexity. Correct approach analysis. The correct approach involves a thorough root cause analysis to understand why the documented procedure was not followed. This aligns with the fundamental principles of a QMS, which emphasizes continuous improvement through problem solving. By investigating the root cause, the organization can implement targeted corrective actions that address the underlying issues rather than just the symptoms. This proactive and systematic approach ensures that the QMS remains effective and that future nonconformities are prevented. This is directly supported by the ISO 9001 standard, assuming this is the relevant framework for the Certified Quality Manager exam, which mandates a process for addressing nonconformities and taking corrective action to prevent recurrence. Ethically, it demonstrates a commitment to quality and integrity. Incorrect approaches analysis. Ignoring the discrepancy and proceeding with the review without addressing the observed deviation is a significant regulatory and ethical failure. It undermines the integrity of the management review process, which is intended to assess the QMS's effectiveness. This approach violates the principle of continuous improvement and can lead to the perpetuation of systemic weaknesses, potentially resulting in more serious issues later. It also fails to uphold the responsibility of a quality manager to ensure compliance and effectiveness. Implementing immediate, superficial changes without understanding the root cause is also problematic. While it might appear to address the issue quickly, it is unlikely to prevent recurrence. This approach is inefficient and does not contribute to genuine QMS improvement. It is a reactive measure that fails to meet the proactive requirements of a robust QMS and can be seen as a form of paper compliance, rather than substantive improvement. Focusing solely on disciplinary action against individuals without investigating systemic issues is another flawed approach. While accountability is important, it is not the primary goal of a management review or a QMS. This approach neglects the opportunity to identify and rectify organizational or process-level failures that may have contributed to the nonconformity. It can also create a culture of fear, discouraging open reporting of issues. This deviates from the systemic focus of quality management and can be counterproductive to achieving lasting improvements. Professional reasoning. Professionals should approach such situations by first recognizing the importance of the management review as a critical feedback mechanism for the QMS. The decision-making framework should prioritize a systematic and data-driven approach. This involves 1. Acknowledging the identified discrepancy and its potential impact. 2. Initiating a structured investigation to determine the root cause. 3. Evaluating the effectiveness of existing controls and procedures. 4. Developing and implementing targeted corrective and preventive actions based on the root cause analysis. 5. Verifying the effectiveness of the implemented actions. 6. Documenting the entire process for transparency and future reference. This framework ensures that actions taken are proportionate, effective, and contribute to the overall improvement of the quality management system, aligning with both regulatory requirements and ethical responsibilities. Question 8. The risk matrix shows a potential for increased product defects originating from different production lines. A quality manager needs to determine if there is a statistically significant difference in the defect rate across these lines to prioritize improvement efforts. Which analytical approach best supports regulatory compliance and effective quality management in this scenario? Option A. Utilize two-way ANOVA to analyze potential interactions between production lines and shift timings. Option B. Focus solely on identifying production lines with the highest raw defect counts without statistical testing. Option C. Implement immediate process adjustments on all production lines to mitigate perceived variations. Option D. Employ one-way analysis of variance ANOVA to compare the mean defect rates across the production lines. The correct answer is D. Employ one-way analysis of variance ANOVA to compare the mean defect rates across the production lines. Explanation. This scenario is professionally challenging because it requires a quality manager to interpret statistical data within the constraints of regulatory compliance and ethical considerations, rather than solely focusing on mathematical outcomes. The pressure to demonstrate compliance and identify root causes for process variations necessitates a thorough understanding of how statistical tools like ANOVA can be applied to support quality objectives, while also recognizing their limitations and potential for misinterpretation. Careful judgment is required to ensure that the chosen analytical approach is both statistically sound and aligned with the organization's quality management system and relevant regulatory standards. The correct approach involves using one-way ANOVA to investigate potential differences in a key quality metric across different production lines. This is the most appropriate method because the scenario implies a single factor, production line, is being examined for its effect on a single outcome variable. One-way ANOVA is designed precisely for this purpose, to determine if there are statistically significant differences between the means of 3 or more independent groups. This aligns with regulatory expectations for demonstrating process control and identifying sources of variation. By applying one-way ANOVA, the quality manager can objectively assess whether observed differences are likely due to random chance or a systematic issue with a particular production line, thereby supporting targeted corrective actions and continuous improvement efforts as mandated by quality management principles and regulatory frameworks that emphasize data-driven decision-making. An incorrect approach would be to immediately implement changes to all production lines based on a superficial observation of variation without statistical validation. This fails to adhere to the principle of evidence-based decision-making, which is fundamental to quality management and regulatory compliance. It can lead to unnecessary costs, disruption, and potentially introduce new problems without addressing the actual root cause. Furthermore, it bypasses the systematic investigation required to identify statistically significant differences, which is a core expectation for demonstrating due diligence in quality control. Another incorrect approach would be to use two-way ANOVA when only one factor is being investigated. Two-way ANOVA is used to examine the effect of two independent variables and their interaction on a dependent variable. Applying it inappropriately would introduce unnecessary complexity and could lead to misinterpretation of results, as it would attempt to analyze interactions that do not exist or are not relevant to the current investigation. This deviates from the principle of using the simplest appropriate statistical tool for the task, which is crucial for clear and accurate reporting and decision-making within a regulated environment. A further incorrect approach would be to focus solely on the p-value, without considering the practical significance or the context of the data. While a low p-value might indicate statistical significance, it doesn't automatically translate to a meaningful difference in a real-world quality context. Regulatory bodies often expect not just statistical proof, but also a demonstration of how the findings impact product quality, customer satisfaction, and compliance. Ignoring practical significance can lead to overreactions to minor variations or underreactions to important ones, undermining the effectiveness of the quality management system. The professional decision-making process for similar situations should involve 1. Clearly defining the quality objective and the specific question to be answered. 2. Identifying the relevant factors and the outcome variable. 3. Selecting the most appropriate statistical tool based on the number of factors and the nature of the data. 4. Conducting the analysis rigorously, considering both statistical significance and practical implications. 5. Interpreting the results in the context of regulatory requirements and organizational goals. 6. Documenting the process and findings thoroughly to support decision-making and future audits. Question 9. Benchmark analysis indicates that a pharmaceutical manufacturing company is facing increased pressure to reduce operational costs while maintaining stringent quality standards. The certified quality manager is tasked with developing the annual internal quality audit schedule. Considering the company's diverse product lines, complex manufacturing processes, and a history of minor deviations in the packaging department, what is the most effective and compliant approach to planning these audits? Option A. Develop an audit schedule that prioritizes auditing critical manufacturing steps, high-risk product formulations, and areas with recent quality concerns or a history of deviations, allocating resources based on the assessed risk level of each area. Option B. Design an audit schedule that primarily targets departments with the most available staff time, ensuring that audits can be conducted with minimal disruption to ongoing production. Option C. Create an audit schedule that focuses on auditing departments with the lowest cost per audit hour, ensuring maximum audit coverage within the allocated budget. Option D. Establish an audit schedule based on a fixed rotation, auditing each department that has not been audited in the last 2 years, regardless of current performance or risk factors. The correct answer is A. Develop an audit schedule that prioritizes auditing critical manufacturing steps, high-risk product formulations, and areas with recent quality concerns or a history of deviations, allocating resources based on the assessed risk level of each area. Explanation. This scenario is professionally challenging because it requires balancing the need for thorough quality assurance with the practical constraints of resource allocation and the potential for disruption. A certified quality manager must exercise sound judgment to ensure that audit activities are effective, efficient, and aligned with organizational objectives and regulatory requirements. The pressure to minimize costs and operational impact can sometimes conflict with the imperative to conduct comprehensive audits. The correct approach involves a risk-based audit planning process that prioritizes areas of highest potential impact on product quality and regulatory compliance. This approach is right because it directly aligns with the principles of effective quality management systems, which emphasize proactive identification and mitigation of risks. Specifically, regulatory frameworks for quality management, such as those governing medical devices or pharmaceuticals, depending on the exam-specific jurisdiction, e.g., FDA regulations in the U.S. or MHRA in the U.K., mandate a systematic approach to identifying and addressing potential nonconformities. An audit plan that focuses on critical processes, high-risk product lines, or areas with recent quality issues is more likely to yield actionable insights and prevent significant quality failures or regulatory breaches. This demonstrates due diligence and a commitment to continuous improvement, which are core ethical and professional responsibilities of a quality manager. An approach that solely focuses on the lowest cost per audit hour is incorrect because it prioritizes financial efficiency over audit effectiveness. This can lead to superficial audits that miss critical issues, potentially resulting in product defects, customer complaints, or regulatory noncompliance, which ultimately incur higher costs. Such an approach fails to meet the professional obligation to ensure product quality and safety. An approach that exclusively audits departments with the most available staff time is also incorrect. While staff availability is a practical consideration, it does not inherently correlate with the risk to product quality or regulatory compliance. Auditing less critical areas simply because staff are available while neglecting high-risk areas is a failure of risk management and can lead to significant oversights. This approach neglects the fundamental purpose of quality audits, which is to assess and improve the effectiveness of the quality management system in preventing and detecting problems. Finally, an approach that only audits departments that have not been audited in the last 2 years, without considering current risk levels or performance, is incorrect. While audit frequency is important, a static schedule without dynamic risk assessment is insufficient. A department that has performed well historically might now be facing new challenges or have implemented significant changes that introduce new risks. Conversely, a department that was recently audited might still warrant a follow-up audit if significant issues were identified or if changes have occurred. This approach lacks the agility and risk-based focus required for effective quality assurance. The professional decision-making process for similar situations should involve a systematic risk assessment. This includes identifying critical processes, evaluating historical performance data, considering customer feedback and complaints, analyzing regulatory requirements and potential changes, and assessing the impact of any new product introductions or process modifications. Based on this risk assessment, an audit plan should be developed that allocates resources to the areas that pose the greatest threat to product quality and regulatory compliance, ensuring that audits are both effective and efficient in achieving their objectives. Question 10. Compliance review shows that on the X-bar and R charts for a critical manufacturing process, several points have fallen outside the control limits over the past week. The production supervisor suggests that these are likely random fluctuations and proposes adjusting the control limits to encompass these recent data points, citing the need to maintain production output without interruption. What is the most appropriate course of action for the certified quality manager? Option A. Increase the frequency of product inspection to catch any non-conforming products that may have been produced during the period of apparent increased variation. Option B. Adjust the control limits to include the recent data points, as this will reflect the current operating conditions and prevent unnecessary production stoppages. Option C. Document the out-of-control points as statistical outliers and continue monitoring the process with the existing control limits. Option D. Initiate an immediate investigation into the special causes of variation that are likely responsible for the out-of-control signals, and implement corrective actions before considering any adjustments to the control limits. The correct answer is D. Initiate an immediate investigation into the special causes of variation that are likely responsible for the out-of-control signals, and implement corrective actions before considering any adjustments to the control limits. Explanation. This scenario is professionally challenging because it requires a quality manager to balance the immediate need for production output with the long-term imperative of maintaining process control and product quality, as mandated by regulatory frameworks. The pressure to meet targets can lead to overlooking subtle but significant shifts in process behavior, which, if unaddressed, can result in non-conforming products and regulatory non-compliance. Careful judgment is required to interpret control chart data accurately and to distinguish between common cause and special cause variation, ensuring that corrective actions are appropriate and effective. The correct approach involves a thorough investigation of the observed out-of-control signals on the X-bar and R charts. This approach correctly identifies that out-of-control points indicate the presence of special cause variation, which requires immediate attention. According to quality management principles and common regulatory expectations for manufacturing, e.g., FDA's Quality System Regulation 21 CFR Part 820 in the U.S., which emphasizes process validation and control, such signals are not to be ignored or attributed to random fluctuations without evidence. The regulatory framework expects that when a process deviates from its established control limits, the root cause must be identified and eliminated to prevent recurrence and ensure product quality and safety. This proactive stance aligns with the principles of continuous improvement and risk management inherent in quality management systems. An incorrect approach would be to dismiss the out-of-control points as mere statistical anomalies or to adjust the control limits without investigating the underlying cause. Dismissing the signals as anomalies fails to acknowledge the fundamental purpose of control charts, which is to detect deviations from expected process behavior. This can lead to a false sense of security while the process continues to produce potentially defective products, violating the regulatory requirement for processes to be in a state of control. Adjusting control limits without root cause analysis is a form of tampering with the process, which is a common pitfall that can actually destabilize a process and increase variation. This action circumvents the regulatory expectation of understanding and controlling process variability. Another incorrect approach would be to focus solely on increasing inspection to catch defects after they occur. While increased inspection might catch some non-conforming products, it does not address the root cause of the variation and is a reactive, rather than proactive, measure. Regulatory frameworks emphasize preventing defects through process control, not just detecting them. Relying solely on inspection is inefficient, costly, and does not demonstrate a commitment to a robust quality management system. Professional decision-making in such situations requires a systematic approach. First, recognize the significance of control chart signals as indicators of process change. Second, apply the principles of SBC to differentiate between common and special cause variation. Third, when special cause variation is detected, initiate a root cause investigation. Fourth, implement corrective and preventive actions based on the findings of the investigation. Finally, monitor the process to ensure the effectiveness of the implemented actions and to maintain the process in a state of statistical control. This structured approach ensures compliance with regulatory expectations and upholds the principles of effective quality management. Question 11. Cost-benefit analysis shows that investing in advanced employee training for quality improvement initiatives and empowering frontline staff with greater autonomy in quality decision-making will incur significant upfront costs, potentially delaying short-term profit targets. However, the analysis also indicates a projected long-term reduction in waste, fewer customer complaints, and improved regulatory compliance. As the certified quality manager, what is the most appropriate leadership approach to champion these quality initiatives within the organization? Option A. Advocate for the immediate implementation of the advanced training and empowerment programs emphasizing the long-term strategic benefits and aligning with the organization's commitment to quality excellence and regulatory adherence. Option B. Implement a system of strict performance metrics and penalties for quality deviation, while deferring investment in employee development and empowerment. Option C. Assign the full responsibility for developing and implementing quality culture initiatives to the Quality Assurance Department, with minimal direct involvement from senior leadership. Option D. Postpone the training and empowerment initiatives until a period of greater financial stability, focusing instead on communicating the importance of quality through existing channels. Correct answer is A. Advocate for the immediate implementation of the advanced training and empowerment programs, emphasizing the long-term strategic benefits and aligning with the organization's commitment to quality excellence and regulatory adherence. Explanation. This scenario is professionally challenging because it requires balancing immediate financial pressures with the long-term strategic imperative of fostering a robust quality culture, directly impacting employee engagement and ultimately organizational performance. The certified quality manager must navigate the inherent tension between cost reduction and investment in quality-enhancing initiatives, which are often perceived as discretionary expenses. Careful judgment is required to ensure that decisions align with the organization's stated commitment to quality and its regulatory obligations, without compromising employee morale or the integrity of quality systems. The correct approach involves leadership actively championing the quality culture by demonstrating commitment through resource allocation and employee empowerment, even when faced with cost pressures. This aligns with the principles of effective quality management, which emphasize the crucial role of leadership in setting the tone and direction for quality throughout the organization. Regulatory frameworks, such as those underpinning quality management systems, e.g., ISO 9001 principles, though specific jurisdiction is not provided, the general principles of leadership commitment are universal in quality standards. Mandate that top management demonstrate leadership and commitment with respect to the quality management system. Empowering employees to identify and address quality issues and providing them with the necessary training and authority is a cornerstone of creating a sustainable quality culture. This fosters a sense of ownership and accountability, leading to continuous improvement and better adherence to quality standards. An incorrect approach that prioritizes short-term cost savings by cutting training and development budgets for quality initiatives, while maintaining superficial communication about quality, fails to address the root cause of potential quality issues and undermines employee confidence. This approach risks creating a disconnect between management's stated goals and the reality on the ground, leading to a decline in quality and potential noncompliance with quality standards. It demonstrates a lack of leadership commitment and fails to empower employees, thereby eroding the quality culture. Another incorrect approach that involves solely relying on punitive measures for quality failures, without investing in preventative measures or employee development, is ethically questionable and professionally unsound. This reactive approach does not foster a culture of learning and improvement. Instead, it can breed fear and a reluctance to report issues, hindering the identification and resolution of systemic problems. It also fails to leverage the potential of empowered employees to contribute to quality improvements. A third incorrect approach that delegates all responsibility for quality culture to a single department without active, visible leadership involvement from senior management is also flawed. While dedicated quality departments are essential, the responsibility for fostering a quality culture rests with all levels of leadership. Without this top-down commitment and active participation, quality initiatives are likely to be perceived as an add-on rather than an integral part of the organization's operations, leading to limited impact and sustainability. The professional decision-making process for similar situations should involve a comprehensive assessment of the long-term implications of any decision on the quality culture and regulatory compliance. This includes understanding the impact on employee morale, engagement, and the effectiveness of quality management systems. Leaders should actively seek to align financial decisions with strategic quality objectives, ensuring that investments in quality are viewed as essential for long-term success and risk mitigation, rather than as optional expenditures. Open communication, employee involvement in decision-making processes related to quality, and a commitment to continuous improvement are vital components of this process. Question 12. System analysis indicates a recurring nonconformance related to documentation errors in batch records. The quality manager is considering two approaches for the COPPA. Approach 1 involves retraining the affected personnel on current documentation procedures and reinforcing the importance of accuracy. Approach 2 involves a comprehensive root cause analysis using tools like a fishbone diagram and 5 whys to identify systemic issues, followed by targeted process improvements and a review of the documentation system's design, in addition to retraining. Which approach best aligns with the principles of effective COPPA for preventing recurrence? Option A, Approach 2, as it addresses potential systemic issues beyond immediate human error and includes verification of effectiveness. Option B, Approach 2, as it involves a more extensive investigation, ensuring all possible causes are explored, regardless of immediate impact. Option C, Approach 1, as it focuses on immediate human factors which are often the primary cause of such errors. Option D, Approach 1, as retraining is a direct and efficient method to address documentation errors. Correct answer is A, Approach 2, as it addresses potential systemic issues beyond immediate human error and includes verification of effectiveness. Explanation. This scenario presents a common challenge in quality management, determining the appropriate scope and depth of a corrective and preventive action, COPPA, investigation when a nonconformance is identified. The professional challenge lies in balancing the need for thorough root cause analysis to prevent recurrence with the practical constraints of resources and time. A superficial investigation risks the nonconformance recurring, while an overly extensive investigation can be inefficient and costly. Careful judgment is required to ensure the COPPA process is effective and compliant with regulatory expectations. The correct approach involves a systematic and data-driven investigation that identifies the true root cause, S, of the nonconformance. This includes gathering objective evidence, analyzing trends, and employing appropriate problem-solving tools to understand not just what happened, but why it happened. The subsequent corrective actions must directly address the identified root cause S, and preventive actions should be implemented to mitigate the risk of similar nonconformances occurring in other areas or processes. This aligns with the principles of quality management systems, such as those outlined in ISO 9001, which mandate effective COPPA processes to drive continuous improvement and ensure product/service conformity. Regulatory frameworks often require documented evidence of root cause analysis and the effectiveness of implemented actions. An incorrect approach that focuses solely on immediate containment without investigating the underlying cause fails to address the systemic issues that led to the nonconformance. This is a regulatory failure because it does not fulfill the requirement for effective corrective action aimed at preventing recurrence. Another incorrect approach, which involves implementing generic or unverified solutions without a clear link to the identified root cause, is also a failure. This can lead to wasted resources and a false sense of security, as the actual problem may remain unaddressed. Furthermore, relying on anecdotal evidence or assumptions rather than objective data during the investigation is a professional and ethical failure, as it compromises the integrity of the COPPA process and the reliability of the resulting actions. Professionals should employ a structured decision-making process for COPPA. This begins with a clear understanding of the nonconformance and its potential impact. Next, a risk-based approach should be used to determine the necessary depth of investigation. This involves gathering relevant data, utilizing appropriate analytical tools to identify root causes, and then developing and implementing targeted corrective and preventive actions. Finally, the effectiveness of these actions must be verified and documented. This systematic approach ensures that COPPA is a tool for genuine improvement and compliance, rather than a mere procedural exercise. Question 13. Process analysis reveals that the yield of a critical manufacturing step is influenced by several factors, including temperature, pressure, and catalyst concentration. To optimize this process for maximum yield, which statistical analysis approach would be most appropriate for identifying the key drivers and their relative impact? Option A, simple linear regression analysis. Option B, correlation analysis. Option C, visual inspection of scatter plots. Option D, multiple regression analysis. Correct answer is D, multiple regression analysis. Explanation. This scenario presents a common challenge in quality management, interpreting statistical findings to drive actionable improvements within a regulated environment. The certified quality manager must not only understand the statistical methods, but also their practical implications and adherence to established quality principles and potential regulatory expectations, even if not explicitly stated in the question. The challenge lies in selecting the most appropriate method for process optimization based on the nature of the data and the desired outcome, while ensuring the chosen method aligns with a systematic approach to quality improvement. The correct approach involves utilizing multiple regression analysis when the quality characteristic is influenced by several independent variables. This method allows for the identification and quantification of the individual impact of each factor, as well as their combined effect on the dependent variable. This is crucial for process optimization, as it enables targeted interventions on the most influential factors, leading to more efficient and effective improvements. This aligns with quality management principles of data-driven decision-making and continuous improvement, ensuring that resources are allocated to address the root causes of variation or defects. An incorrect approach would be to solely rely on simple linear regression, when multiple factors are known to influence the outcome. Simple linear regression assumes a single independent variable, and applying it in a multivariate situation would lead to an incomplete understanding of the process, potentially misattributing effects or overlooking significant drivers of variation. This could result in suboptimal process adjustments and a failure to achieve desired quality levels, potentially contravening the spirit of regulatory expectations for robust quality systems. Another incorrect approach is to focus only on correlation analysis without considering the causal relationships or the predictive power of the variables. Correlation simply indicates the strength and direction of a linear relationship between two variables, but it does not imply causation. Using correlation alone for process optimization might lead to interventions based on spurious relationships, failing to address the true drivers of process performance, and thus not leading to genuine improvement. This can be seen as a failure to apply rigorous analytical methods expected in quality management. A further incorrect approach would be to select a method based on ease of implementation rather than its suitability for the problem. While simplicity is desirable, it should not come at the expense of analytical rigor. Choosing a method that does not adequately represent the complexity of the process would undermine the quality improvement initiative and could lead to flawed conclusions and ineffective actions. The professional decision-making process in such situations involves a thorough understanding of the process being analyzed, the nature of the data collected, and the specific objectives of the analysis. It requires evaluating the assumptions and capabilities of different statistical techniques, such as simple linear regression, multiple regression, and correlation analysis, in the context of process optimization. The quality manager must then select the method that provides the most comprehensive and accurate insights for driving meaningful improvements, ensuring that the chosen method supports data-driven decision-making and aligns with the principles of effective quality management. Question 14. The performance metrics show that two different production lines, line A and line B, have significantly different output defect rates. Preliminary analysis suggests that the defect rate data for both lines is not normally distributed and may have unequal variances. As a certified quality manager, which statistical approach would be most appropriate to rigorously compare the defect rates between line A and line B to determine if a statistically significant difference exists, thereby informing targeted quality improvement efforts? Option A. Utilize the Mann-Whitney U-test to compare the two independent samples. Option B. Proceed with an independent samples t-test, assuming the sample sizes are large enough to overcome normality violations. Option C. Apply a logarithmic transformation to the defect rate data and then perform an independent samples t-test. Option D. Conduct a visual inspection of the raw data and make a determination based on observed trends. Correct answer is A. Utilize the Mann-Whitney U-test to compare the two independent samples. Explanation. This scenario is professionally challenging because it requires a quality manager to select an appropriate statistical method for comparing two independent groups when the assumptions for parametric tests are not met. The challenge lies in understanding the limitations of parametric tests and the strengths of non-parametric alternatives, ensuring that the chosen method leads to valid conclusions and supports effective quality improvement initiatives. Misinterpreting the data or applying an inappropriate statistical test could lead to flawed decision-making, wasted resources, and a failure to address the root causes of performance discrepancies. The correct approach involves utilizing the Mann-Whitney U-test. This non-parametric test is specifically designed to compare two independent samples when the data is ordinal or when the assumptions of normality and equal variances for parametric tests, like the independent samples t-test, are violated. The Mann-Whitney U-test assesses whether one of the two samples tends to have larger values than the other, without assuming a specific distribution for the underlying populations. This aligns with the certified quality manager's responsibility to use robust and appropriate analytical tools to identify and address quality issues, ensuring decisions are based on sound statistical evidence, even when dealing with non-normally distributed data. Regulatory frameworks for quality management often emphasize the need for data-driven decision-making and the use of appropriate statistical methods to ensure product or service quality and compliance. An incorrect approach would be to proceed with an independent samples t-test, despite the data not meeting the normality assumption. This is a regulatory and ethical failure because it violates the principle of using valid statistical methods. The t-test's reliability is compromised when its underlying assumptions are not met, potentially leading to incorrect conclusions about whether a statistically significant difference exists between the two groups. This could result in the misallocation of resources for quality improvement efforts or the failure to implement necessary corrective actions, thereby undermining the organization's commitment to quality and potentially leading to noncompliance with quality standards. Another incorrect approach would be to ignore the statistical analysis altogether and make a decision based solely on anecdotal evidence or a superficial review of the performance metrics. This is a significant professional failure as it bypasses the rigorous, data-driven approach expected of a certified quality manager. It disregards the need for objective evidence to support quality-related decisions, which is a cornerstone of most quality management systems and regulatory expectations. Such an approach can lead to biased decisions, missed opportunities for improvement, and a lack of accountability. A third incorrect approach would be to attempt to transform the data to fit the assumptions of a parametric test without a thorough understanding of the implications of such transformations. While data transformation can sometimes be a valid technique, it can also distort the data's original meaning and relationships, potentially leading to misleading results. Without a strong statistical justification and a clear understanding of how the transformation affects the interpretation of the results, this approach risks invalidating the analysis and leading to incorrect conclusions, which is a failure in professional due diligence. The professional decision-making process for similar situations should involve a systematic evaluation of the data's characteristics, including its distribution. When comparing two independent groups, the quality manager should first assess whether parametric assumptions, normality, homogeneity of variances are met. If they are not, the next step is to identify and apply an appropriate non-parametric alternative, such as the Mann-Whitney U-test. This ensures that the analysis is statistically sound and that the conclusions drawn are reliable, supporting effective quality management practices and regulatory compliance. Question 15. The audit findings indicate a recurring pattern of customer complaints related to product defects. As the certified quality manager, which analytical approach would be most effective in identifying the primary drivers of these complaints and validating potential root causes, ensuring compliance with quality management principles for continuous improvement? Option A. Rely on the experience of senior management to determine the most likely causes of the defects. Option B. Immediately implement a company-wide training program on general quality awareness. Option C. Conduct a series of brainstorming sessions with the production team to generate ideas for product improvements. Option D. Utilize Pareto analysis to identify the most frequent defect types, and then employ hypothesis testing to validate the root causes of these prioritized defects. The correct answer is C. Conduct a series of brainstorming sessions with the production team to generate ideas for product improvements. Explanation. This scenario is professionally challenging because it requires a quality manager to move beyond superficial problem identification to a rigorous, data-driven root cause analysis, adhering to established quality management principles and potentially regulatory requirements for process improvement and corrective action. The pressure to quickly implement solutions without fully understanding the underlying issues can lead to ineffective or even detrimental interventions. Careful judgment is required to select the most appropriate analytical tool for the specific context of the audit findings. The correct approach involves using Pareto analysis to identify the most significant contributing factors to the audit findings, followed by a hypothesis testing framework to validate potential root causes. Pareto analysis, by prioritizing issues based on frequency or impact, allows for efficient allocation of resources to address the most critical problems first, aligning with the principle of focusing on significant deviations. Hypothesis testing then provides a structured, empirical method to confirm or refute suspected root causes, ensuring that corrective actions are targeted and effective, thereby meeting the quality management objective of preventing recurrence and driving continuous improvement. This methodical approach is ethically sound, as it promotes responsible use of resources and aims for genuine, sustainable solutions. An incorrect approach would be to immediately jump to implementing solutions based on anecdotal evidence or the most obvious symptoms without a systematic analysis. This fails to address the true root cause, leading to wasted effort and potential recurrence of the issues, which is a failure in professional due diligence and can be seen as a breach of ethical responsibility to ensure effective quality management. Another incorrect approach is to solely rely on brainstorming without structured data collection or analysis to identify root causes. While brainstorming can generate ideas, without a framework to prioritize and validate them, it lacks the rigor required for effective problem solving and can lead to pursuing less impactful issues while neglecting the primary drivers of the audit findings. This also falls short of the professional obligation to employ evidence-based quality management practices. Professionals should employ a decision-making framework that begins with clearly defining the problem based on audit findings. Next, they should select the most appropriate analytical tools, e.g., Pareto, fishbone diagram, 5 whys, to explore potential causes. Once potential root causes are identified, a structured method like hypothesis testing should be used to validate them. Finally, based on validated root causes, effective and sustainable corrective actions should be developed and implemented, with a plan for monitoring their effectiveness. Question 16. Stakeholder feedback indicates a recurring issue with the usability of a recently updated software feature. While some stakeholders are requesting immediate changes to address their specific pain points, others are concerned about the potential impact of rushed modifications on system stability. As a certified quality manager, what is the most appropriate initial course of action? Option A. Immediately implement the most frequently requested changes from stakeholders to demonstrate responsiveness and address their immediate concerns. Option B. Initiate a formal root cause analysis process to thoroughly investigate the feedback, gather relevant data on user interactions and error logs, and identify the underlying reasons for the usability issues before proposing solutions. Option C. Conduct a quick survey of a small group of users to gauge their general satisfaction and make minor adjustments based on the most common responses. Option D. Classify the feedback as minor user preference issues and focus on other critical quality initiatives, assuming the majority of users will adapt. The correct answer is B. Initiate a formal root cause analysis process to thoroughly investigate the feedback, gather relevant data on user interactions and error logs, and identify the underlying reasons for the usability issues before proposing solutions. Explanation. This scenario is professionally challenging because it requires balancing immediate stakeholder demands with the need for a robust, data-driven quality improvement process. Rushing to implement a solution without understanding the root cause can lead to wasted resources, ineffective fixes, and further stakeholder dissatisfaction. Careful judgment is required to ensure that decisions are not only responsive, but also sustainable and aligned with quality management principles. The correct approach involves systematically investigating the feedback to identify the underlying issues. This aligns with the core principles of quality management, which emphasize continuous improvement through data analysis and problem solving. Specifically, it adheres to the foundational concept of root cause analysis, a critical component of effective quality management. By gathering and analyzing data related to the feedback, the quality manager can move beyond symptoms to address the fundamental reasons for the dissatisfaction. This methodical process is ethically sound, as it prioritizes genuine problem resolution over superficial fixes, thereby upholding the integrity of the quality management system and stakeholder trust. An incorrect approach that immediately implements a change without investigation fails to address the actual problem. This can lead to a situation where the perceived issue is resolved, but the real root cause persists, potentially manifesting in other ways or leading to new problems. This is a failure in professional responsibility as it bypasses due diligence and relies on assumption rather than evidence, which is contrary to the data-driven decision-making expected of a certified quality manager. Another incorrect approach that dismisses the feedback as minor or isolated, without proper investigation, is also professionally unacceptable. This demonstrates a lack of responsiveness to stakeholder concerns and a failure to recognize potential systemic issues. Ethically, it neglects the duty to address legitimate feedback that could impact product or service quality and customer satisfaction. It also undermines the principles of a proactive quality management system that seeks to identify and mitigate risks before they escalate. The professional decision-making process for similar situations should involve a structured approach. 1. Acknowledge and document all stakeholder feedback. 2. Prioritize feedback based on potential impact and urgency. 3. Initiate a data-gathering phase to understand the scope and nature of the issue. 4. Employ appropriate problem-solving techniques, e.g., Ishikawa diagrams 5 whys, to identify the root cause. 5. Develop and implement corrective and preventive actions based on the identified root cause. 6. Monitor the effectiveness of implemented actions and communicate results to stakeholders. This framework ensures that decisions are informed, evidence-based, and contribute to genuine quality improvement. Question 17. The risk matrix shows a moderate likelihood of customer complaints related to product dimensional deviations. The quality manager is reviewing process capability data for the critical manufacturing step. The short-term capability indices, CP, CPK, are within acceptable limits, suggesting the process has the potential to meet specifications. However, the long-term capability indices, PP, PPK, are significantly lower, indicating that the actual process output over time is more variable than initially suggested by the short-term data. Considering the regulatory framework for quality management and the need to mitigate risks of non-conforming product, which interpretation of these capability indices best supports a proactive quality management strategy? Option A. Prioritize the interpretation of the long-term capability indices, PP, PPK, as they reflect the actual process performance over time, which is more indicative of sustained compliance and risk of deviation. Option B. Focus on the short-term capability indices, CP, CPK, as they demonstrate the inherent potential of the process to meet specifications, and any improvement efforts should aim to maintain these values. Option C. Recommend immediate process shutdown and recalibration based on the discrepancy between short-term and long-term indices, assuming a critical failure has occurred. Option D. Conclude that the process is adequately capable because the short-term indices meet the required thresholds, and the lower long-term indices are likely due to random fluctuations that do not pose a significant risk. The correct answer is B. Focus on the short-term capability indices, CP, CPK, as they demonstrate the inherent potential of the process to meet specifications, and any improvement efforts should aim to maintain these values. Explanation. This scenario is professionally challenging because it requires a certified quality manager to interpret process capability indices not just as statistical measures, but as indicators of compliance with regulatory requirements and potential risks to product quality and customer safety. The pressure to demonstrate improvement without fully understanding the implications of different capability metrics can lead to misinterpretations and flawed decision-making. A robust understanding of the nuances between short-term CP, CPK, and long-term PP, PPK process capability is crucial for accurate assessment and effective quality management. The correct approach involves recognizing that while CP and CPK provide insights into the inherent variability of a process relative to specification limits over a short period, PP and PPK reflect the actual variation observed over a longer, more representative timeframe, including potential shifts or drifts. For regulatory compliance and risk assessment, understanding the long-term performance, PP, PPK, is paramount. This is because regulatory bodies and customers are concerned with the actual output of the process over time, not just its theoretical potential under ideal conditions. A process that appears capable in the short term, high CP, CPK, but exhibits significant drift or shifts over the long term, low PP, PPK, poses a greater risk of non-conforming product reaching the market. Therefore, prioritizing the interpretation of PP and PPK for risk assessment and continuous improvement initiatives, aligns with the ethical responsibility to ensure consistent product quality and adherence to established standards, which are often implicitly or explicitly tied to long-term performance. An incorrect approach would be to solely focus on CP and CPK as indicators of quality improvement. This fails to account for the real-world variability and potential process shifts that occur over extended production runs. Ethically and regulatorily, this is a failure because it provides an incomplete and potentially misleading picture of process performance, increasing the risk of non-compliance and product defects. Another incorrect approach is to assume that any positive trend in CP or CPK automatically signifies regulatory compliance without considering the long-term perspective. This overlooks the fact that regulatory frameworks often mandate stable and predictable processes, which are best assessed through long-term capability measures. Furthermore, making decisions solely based on short-term potential without validating with long-term performance can lead to a false sense of security and inadequate corrective actions. Professional decision-making in such situations requires a systematic approach. First, clearly define the purpose of the analysis, e.g., risk assessment, regulatory reporting, process improvement. Second, understand the differences between short-term and long-term capability metrics and their respective applications. Third, prioritize the interpretation of long-term capability PPK for assessing actual process performance and compliance risk. Fourth, use short-term capability CPK to understand the inherent potential of the process and identify opportunities for improvement in process stability and control. Finally, communicate findings clearly, highlighting the implications of both short-term and long-term capability for quality and compliance. Question 18. Market research demonstrates a growing interest in understanding the foundational principles that have shaped modern quality management practices. A certified quality manager is tasked with explaining the collective impact of key historical figures on the development of quality management systems. Which of the following best represents the integrated contribution of Deming, Jurin, Crosby, and Ishikawa to the evolution of quality management? Option A. The integrated contribution is solely defined by Philip Crosby's quality is free philosophy, with other figures' ideas being secondary or irrelevant to modern quality management. Option B. The integrated contribution is limited to the implementation of specific quality control charts, with little regard for broader management system principles or customer satisfaction. Option C. The integrated contribution emphasizes statistical process control, quality planning and assurance, the pursuit of zero defects, and the use of quality tools for problem solving, all of which have influenced contemporary quality frameworks and standards. Option D. The integrated contribution primarily focuses on the development of advanced statistical software and automation, rendering earlier quality philosophies largely obsolete. The correct answer is C. The integrated contribution emphasizes statistical process control, quality planning and assurance, the pursuit of zero defects, and the use of quality tools for problem solving, all of which have influenced contemporary quality frameworks and standards. Explanation. This scenario is professionally challenging because it requires a certified quality manager to navigate the historical evolution of quality management principles and apply them to a modern organizational context, while adhering to the specific regulatory framework of the Certified Quality Manager exam. The challenge lies in discerning which historical contributions are most relevant and how they align with current quality standards and regulatory expectations, without misinterpreting or misapplying foundational concepts. Careful judgment is required to ensure that the chosen approach reflects a comprehensive understanding of quality's historical trajectory and its impact on contemporary practices. The correct approach involves recognizing that the evolution of quality management is not a linear progression, but rather a series of interconnected developments. Key figures like Deming, Jurin, Crosby, and Ishikawa introduced distinct yet often complementary philosophies. Deming emphasized statistical process control and continuous improvement. Jurin focused on quality planning, control, and improvement. Crosby championed quality is free and zero defects, and Ishikawa developed the cause-and-effect diagram and a participatory approach to quality. A comprehensive understanding acknowledges these contributions and their collective influence on modern quality management systems, such as ISO 9001, which embodies many of these principles in its requirements for process approach, customer focus, and continual improvement. This approach is correct because it demonstrates a deep understanding of the foundational principles that underpin current quality management standards and regulatory expectations, showing how historical insights inform best practices. An incorrect approach would be to solely focus on one historical figure's contribution while neglecting others, or to assume that later developments have entirely superseded earlier ones. For instance, focusing exclusively on Crosby's zero defects, without acknowledging Deming's statistical process control, might lead to an incomplete or unbalanced quality strategy. This is a regulatory and ethical failure, because it demonstrates a superficial understanding of quality management's evolution, potentially leading to the implementation of ineffective quality initiatives that do not fully leverage the breadth of established quality knowledge. It also fails to meet the implicit expectation of a certified quality manager to possess a holistic view of the discipline. Another incorrect approach would be to dismiss historical figures as outdated and irrelevant in the face of modern technology and methodologies. This fails to recognize that the core principles of quality management, such as understanding variation, customer satisfaction, and systematic problem-solving, remain fundamental, regardless of the tools used. Ethically, this approach shows a lack of respect for the foundational work that has shaped the field and could lead to reinventing the wheel, missing opportunities for proven solutions. It also violates the spirit of continuous learning and the application of established knowledge expected of a certified professional. The professional reasoning process for similar situations should involve 1. Identifying the core question or problem. 2. Recalling the foundational principles and historical development of the relevant quality management concepts. 3. Evaluating each historical contribution for its relevance and impact on current best practices and regulatory requirements. 4. Synthesizing this knowledge to form a comprehensive understanding. 5. Applying this understanding to the specific context, ensuring that the chosen approach is well justified by both historical precedent and current standards. This systematic approach ensures that decisions are informed, robust, and ethically sound, reflecting a deep mastery of the subject matter. Question 19. Upon reviewing the initial data collected for the on-time delivery metric in the logistics department, the quality manager observes significant inconsistencies that do not align with anecdotal feedback from the sales team regarding customer satisfaction. The team is eager to start process mapping to identify bottlenecks. What is the most appropriate next step for the quality manager to ensure the integrity of the subsequent analysis and improvement efforts? Option A. Immediately proceed with detailed process mapping of the entire delivery workflow to identify potential bottlenecks based on the collected data. Option B. Assume the data is accurate and proceed with process mapping, focusing on identifying areas where delays are most frequently recorded in the current dataset. Option C. Rely on the experience of the logistics supervisors to interpret the data and identify areas for improvement, as they have been managing the process for years. Option D. Conduct a measurement system analysis, MSA, on the on-time delivery data collection process to evaluate its accuracy and precision before proceeding with further analysis. The correct answer is A. Immediately proceed with detailed process mapping of the entire delivery workflow to identify potential bottlenecks based on the collected data. Explanation. This scenario presents a common challenge in the measure phase of quality management, ensuring the reliability and validity of data collected for process improvement. The professional challenge lies in balancing the need for timely data with the imperative to have accurate and trustworthy measurements. A flawed measurement system can lead to incorrect conclusions, wasted resources on ineffective solutions, and ultimately, failure to achieve desired quality improvements. Careful judgment is required to identify potential biases and inaccuracies in data collection methods. The correct approach involves conducting a thorough measurement system analysis, MSA, before fully committing to process mapping and subsequent analysis. MSA is a critical quality tool that assesses the variation introduced by the measurement system itself. This includes evaluating the accuracy, precision, linearity, and stability of the measurement process. By understanding the capabilities and limitations of the measurement system, quality managers can ensure that the data collected accurately reflects the true process performance, rather than being skewed by measurement error. This aligns with the fundamental quality principle of using reliable data for decision-making, which is implicitly supported by most quality management frameworks that emphasize data-driven improvement. An incorrect approach would be to proceed with process mapping and analysis without verifying the measurement system. This is professionally unacceptable because it risks building an entire improvement strategy on faulty data. If the measurement system is not capable, the process maps will not accurately represent the actual process flow or identify true sources of variation. This can lead to misdirected efforts, ineffective root cause analysis, and the implementation of solutions that do not address the real problems, potentially violating ethical obligations to stakeholders to deliver genuine improvements. Another incorrect approach is to rely solely on anecdotal evidence or the opinions of experienced operators to validate the measurement system. While operator input is valuable, it does not replace the systematic and objective evaluation provided by MSA. Relying only on opinions can introduce subjective bias and overlook subtle but significant measurement errors that can have a substantial impact on data interpretation. This approach fails to meet the professional standard of rigorous data validation. Finally, an incorrect approach would be to assume that a measurement system is adequate simply because it has been used for a long time without apparent issues. Historical usage does not guarantee current capability, especially if process conditions or equipment have changed. A proactive quality manager must periodically reevaluate measurement systems to ensure their continued suitability. The professional decision-making process for similar situations should involve a systematic approach. First, understand the critical to quality characteristics, CTQ, of the process. Second, identify the measurement methods and equipment used to capture data related to these CTQs. Third, plan and execute an appropriate MSA to assess the reliability of the measurement system. Fourth, if the MSA reveals issues, address them before proceeding with extensive process mapping and data analysis. This ensures that improvement efforts are based on sound, reliable data, fulfilling the professional responsibility to drive effective quality enhancements. Question 20. Stakeholder feedback indicates a strong desire to expedite the launch of a new product line. However, the initial market research, while broad, did not deeply probe specific customer pain points or desired outcomes. The project team is eager to move forward with project selection and charter development, proposing to define critical to quality (CTQ) characteristics based on internal engineering capabilities and perceived market trends, rather than a detailed analysis of the voice of the customer (VOC) for this specific product. What is the most appropriate initial action for the certified quality manager? Option A. Proceed with project selection and charter development using the existing market research, assuming internal capabilities will guide the most feasible CTQs. Option B. Suggest a compromise by incorporating a few high-level customer requests into the charter, while prioritizing internal operational efficiency for the majority of CTQs. Option C. Advocate for a pause in project selection and charter development to conduct a focused VOC study to identify and validate CTQ characteristics before proceeding. Option D. Recommend defining CTQs based on easily measurable internal performance indicators that the engineering team can readily achieve. Correct answer is C. Advocate for a pause in project selection and charter development to conduct a focused VOC study to identify and validate CTQ characteristics before proceeding. Explanation. This scenario presents a professional challenge because it requires balancing competing stakeholder interests and ensuring that the project's foundation is built on accurate and ethically obtained customer needs, rather than potentially biased internal assumptions. The certified quality manager must navigate the tension between immediate operational pressures and the long-term strategic imperative of customer satisfaction. The ethical dilemma arises from the potential to overlook or misinterpret the voice of the customer (VOC), to expedite project selection or charter development, which could lead to a project that ultimately fails to deliver value or even causes dissatisfaction. The correct approach involves rigorously defining the critical to quality (CTQ) characteristics based on a comprehensive understanding of the voice of the customer (VOC). This means actively seeking, documenting, and analyzing direct customer input to identify what truly matters to them. The project charter should then clearly articulate how the project will address these CTQs, ensuring alignment with customer expectations from the outset. This aligns with the fundamental principles of quality management, which emphasize customer focus and data-driven decision-making. Ethically, It upholds the commitment to delivering value and meeting customer needs, preventing the misallocation of resources on projects that do not address genuine requirements. An incorrect approach would be to proceed with project selection and charter development based solely on internal assumptions about customer needs, without a robust VOC process. This fails to adhere to the core quality principle of customer focus and risks creating a project that is misaligned with market demands. Ethically, it is a failure to be transparent and accountable to the customer, potentially leading to wasted resources and damaged reputation. Another incorrect approach would be to superficially gather VOC data, but then prioritize internal operational preferences or perceived quick wins over what the VOC truly indicates as critical. This undermines the integrity of the VOC process and the CTQ definition. Ethically, it represents a form of deception, as customer input is solicited but then disregarded in favor of internal agendas, failing to act in the customer's best interest. A further incorrect approach involves defining CTQs based on easily measurable internal metrics that may not directly correlate with customer satisfaction. While internal metrics are important for project execution, they should be derived from and validated against customer needs. Focusing solely on internal metrics without a strong VOC foundation leads to a project that might be efficient but irrelevant to the customer. Ethically, this is a failure to genuinely understand and respond to customer requirements, potentially leading to a product or service that is technically sound but fails to meet customer expectations. The professional decision-making process for similar situations should involve 1. Prioritizing the establishment of a robust VOC process to gather authentic customer feedback. 2. Ensuring that CTQ characteristics are directly derived from and validated by this VOC data. 3. Developing the project charter to clearly reflect the project's commitment to addressing these CTQs. 4. Challenging internal assumptions and biases that may conflict with customer feedback. 5. Escalating concerns if there is resistance to incorporating genuine customer needs into project definition.